Okay, so in this video we're looking at ionic bonding. An ionic bond is the electrostatic attraction between ions of opposite charge. So a positive ion attracted to a negative ion. So one thing we've got to be able to do is draw a dot-cross diagram of these ions. So the positive ion has come about because a species has lost an electron and become positive, and the negative ion has come about because a species has gained an electron and become negative. So here we've got calcium sulfide. Calcium would lose 2 electrons because the ionization energies in metals is low compared to non-metals, and the non-metals have a high electron affinity. They want to gain electrons. So the non-metal would gain the electrons. So here we go. We have a calcium with a 2+ ion and the sulfide with a 2-. So the outer shell shows that the sulfide ion has gained 2 electrons. That's why it's got a 2- charge. We don't need to show the outer shell, the calcium, because we've lost the 2 electrons that were in the original outer shell. We must show them as dots and crosses to show that the sulfur started off with 6 electrons and now it's gained 2. Okay, another one similar to this is ammonium chloride, another ionic compound. So here we can see that here we've got the ammonium ion. Notice here's a dative bond. 2 electrons here. Both these electrons have both come from the nitrogen to make a dative bond to the hydrogen. It's got a plus charge overall, and it's attracted to the chloride ion. The chlorine starts off with 7 electrons out of the shell. It gains 1 to make the chloride ion. Positive and negative attract to each other. Both these examples have 1 ion each because the charges, though opposite, are equal. In this case, we have 2 fluoride ions for every 1 magnesium ion. So magnesium has 2 electrons in its outer shell because it's in group 2, so it loses both those electrons. Each fluorine can only gain 1 electron to become fluoride, so we need 2 fluorines to make 2 fluorides, 2 lots of F-. Okay, so these ions come together in a giant ionic lattice like this. So you can see here, if you look at this red one here, the red ones which tells us that represent the sodium ions. And here you can see that sodium ion is surrounded by 1, 2, 3, 4, 5, 6 green dots there which represent the chloride ions. So each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions, and that makes a giant ionic lattice. Okay? There's strong electrostatic attractions between these ions, making it a very strong bond. And that's why ionic compounds have such high melting points and boiling points, because to be able to melt it, you have to separate the ions, and that's difficult to do. It takes a lot of energy because of strong electrostatic attraction between the ions. Now, if you want to draw this, you can draw it like that if you feel comfortable, but another way of representing it is to draw a sodium ion surrounded by 6 chlorides, and a chloride surrounded by 6 sodiums, and refer to this as 2 sections of the ionic lattice. Okay, so how does the structure affect the properties? As we just said, ionic compounds have high melting points because of the strong electrostatic attraction between the ions. Can they conduct electricity? Well, when solid, no. Ionic compounds cannot conduct electricity, but when molten, so if we melt it, as in this diagram shows here, they do conduct electricity. And when in solution, so dissolved in water, again, they conduct electricity. And the reason for this is because the ions need to be able to move. In solid, they're attracted to each other in fixed lattice positions. They can't move. But when heated up and melted or dissolved in water, the ions are free to move and therefore can conduct electricity. Ionic compounds, majority of them dissolve in water because the water molecules have delta plus, delta minus dipoles on their polar molecule, and the delta plus is attracted to the negative ions. The delta minus here you see attracted to the positive ion. In this case it's a sodium ion, and so it gradually just hydrates the ionic compound, pulling apart the lattice, and then those ions can move in solution. Okay, so when they're solid, the ions can't move, they don't conduct electricity. When they're molten, then they move.